Okay, so we'll have a test on chapters 3 and 4.
When?
On Friday.
Wow.
We're reviewing today and tomorrow. So.
Are we going to go over that chart?
Yes. We will. Well, let's go over this first. All right, so in 3.1, we drew angles, right?
Yeah.
So for that, remember, right, you have the plane, you have X and Y. Your initial side is always here. All right, terminal side is the other one. So remember, a positive angle goes up and around.
What is the key in the
Initial and terminal. Yeah. I love that people close doors. Oh, okay. They came back and fixed it. Good job. All right. Yeah, this was from 3.1, so we've done this before.
What's that key stand for?
Terminal. Yeah, all that should be in your notes. Right. Remember, if you have a negative angle measure, you measure the other way. So yellow is positive, blue is negative. I have some back there if you need them. I have colors back there if you need it. Jersey, put your phone away.
I was taking a picture of it because you switched it.
Oh, okay. I'm also going to post this video on LMS, so.
Are you taking it?
I am, because Emma's not here. Everybody say hi to Emma.
I am. Where did Emma go?
She left.
She's sick. She left.
Oh.
Okay, now that we've all said hi to Emma. All right, so you'll have to use a protractor to draw, label the terminal initial sides. Fairly straightforward for that. The other thing we did was found the coterminal angles. Right, this is where you add and subtract 360. Okay, so let's say we have 375 degrees. So to find angles that are coterminal with that, what do I want to do? Okay, so we can subtract 360. And that gives us what? Okay, what happens if we subtract 360 again? Okay, and that's okay, right? Uh-huh. All right, so 15 is coterminal, negative 345 is coterminal. What happens if we add a 360 to 375?
Wait,
What?
It can't be a negative.
it can't be a negative.
That's for reference angles. Just in general, coterminal angles can. These are the ones you want between the negative 720 and 720. We're just finding angles that look the same right now.
Oh.
But
When you're finding a reference angle, you want to make it positive in between 0 and 360. But we had to learn how this worked first.
Can you plus that and make it something else?
You can. You can also add a 360.
Couldn't you plus the top?
oh yes, it can't be more than 360, right? Like
It can.
if you minus. I'm talking about the red one. Well, that would be-
Where? Here?
Yeah,
What part? Here?
the 345.
Yeah.
You can't minus 360 again because it'll make it more than.
I mean, you honestly technically could because that's too big. But yeah. Basically, I want you finding three. Basically, I want you just to find 3. So, like, you could do these 3. You could also subtract another 360 and get, so you can do negative 345. 720.
720 negative and
No.
720 positive.
Yeah. So, like, I would accept any of those at that point.
But
You said 720.
is bigger than.
Yes. That's true. So, in this case, you're subtracting, right? More than likely, you'll have to add at least once. I'll either say keep it between 720 or I'll just tell you to find me 3.
Okay.
Either one. I just want you to know how to find them. I'm not super worried about where they stop. I want you to understand that you can add and subtract 360 to make angles that look the same. Okay? All right. Are we good? Okay. All right, so any questions on 3.1? That's it. Bless you. That was
No,
like
we're
the
having-
most adorable sneeze ever.
Thank
It
you.
was very,
That's the only thing that's on or
no,
there's more.
yes.
When I hit equal sign on my keyboard, it automatically did the math for me.
Interesting.
On one more?
If you do it, then it's. How did you get 720?
I did 345, negative 345 minus another 360. Okay. So, moving on to 3.2. So this is when we converted from degrees to radians, radians to degrees. Okay, so if we wanted to go from degrees to radians, how do we do that? What do we multiply by?
I know this.
Do you really?
180 did. 180 or 360.
Good job, Caitlin. Pi over 180. So let's do
Then
an
you flip it for the
yes. So let's do an example. Somebody give me a number.
52.
Ugh.
152.
I want something that reduces nicely.
20.
60.
20.
So that would become pi over 9. Right, so radians should have pi left in your answer. More than likely in a fraction form. Not always, but most of the time.
So
Could
like,
you just do 20 pi over 180?
Well, you'd have to reduce it. Yeah.
I don't know if this is a different thing, but like, I feel like I've seen a number and then pi, and then it divides and does the thing on the bottom.
Yeah, that's okay.
Yeah.
Same thing.
What if you have like 3 pi over 3? Is that just, that's just plain pi then?
Mm-hmm.
Okay.
Yes, it does.
Wait, do you put... Wait, do you have to put 20 up above 180?
Mm-hmm.
Huh?
Because technically it's like 20.
times pi over 180?
Yes. Right, and then so when you go radians to degrees, as Micah said, you go the other way. So you flip that fraction. So let's do 3 pi over 7. So we multiply by 180 over pi. So the pi's cancel. So technically you're doing 180 times 3 divided by 7. Ew. I don't like that. Mm-hmm. Oh, yeah, that's right. So you get 77.14. All right, so for the degrees, it's okay to get a decimal. You said 77 degrees there. Okay, how we feel? Good?
Feel good.
Anybody still writing? Okay. All right, so then we jumped ahead to chapter 4. I know, the first part of this book is weird and I don't like it. The rest of it will pretty much go chapter by chapter. I don't know. What are you doing? All right, so in 4.1, this is where I gave you the points and you had to find the trig functions. So like you had to say I gave you the point -9, -12. Right, and then so it's -9.
Oh.
So like your point's here, so then you're drawing your triangle. So then you have to use the Pythagorean theorem, right?
I should do this.
Okay, so your hypotenuse is 15. Right, so you have to find that first. And then you remember your reference angle is always up here. Right, it's touching that x-axis. So then now you have to find your trig functions. Right, so we're finding sine. So that would be -12/15, right? I'll go back and reduce in a minute. Cosine is -9/15. Tangent is -12/-9. So reducing those, you get -3/5. No, you don't. 4/5. And then you can find your inverse ones. So cosecant would be, you flip sine, secant, flip cosine, and cotangent, you flip tangent.
Is the ACT on the computer? That's a random question, but is it like?
Not that I know of at this point.
So it's on paper.
As far as I know, yes. I know they've talked of changing it, but all right, so how do we feel about this part?
Good.
Good? Okay. All right, can I move on? Or we need a second? Okay.
I know we done moved on.
All right, and then the next part we did here was when we had our all students take calculus, right? So here, sine, cosine, and tangent are all positive. Did you say you hated this?
I just.
This is the easy part.
On the test, we're not gonna have like we have to memorize which one's negative, right?
Yeah. Which one's positive, really?
Do we have to memorize like what that stuff we did yesterday?
No. You'll have the unit circle.
Like minus 180. Like you remember when we had to have formulas for which?
Oh, for the
quadrants?
reference angles? Yeah, that's stuff you need to know.
Yeah, this wasn't, like, we're gonna have to memorize which ones?
All right, we're not there yet. So then in quadrant 3, tangent is positive. Right, so this one, it'll give you like, if cosine is less than 0 and tangent is greater than 0. So you have to find the quadrant where cosine is negative, but tangent is positive. So where does that happen?
3.
Yep, in quadrant 3. All right, so remember you have 1, 2, 3, 4. So like on the test, it'll give you something like what's in red. And I'll just ask you what quadrant that angle would be in.
But isn't tangent positive in number 1 too? So why would it only be?
Because cosine also has to,
okay.
yeah, that's why it gives you 2.
Yeah, got it.
Yep. So if they were both positive, then yes, it would be quadrant 1.
Got it.
Yep, good question. Okay, that was pretty much it in 4.1.
Still 4.1.
Okay? So any questions on that? How do we feel? Pretty good? Good-ish? Okay. So then in 4.2, that was our reference angles.
Oh, yeah.
So these are the ones where you'll have to know what formula to use.
This is what I don't.
So what you don't get?
This isn't
No, I'm
bad.
just scared I'm gonna mess up on like the 360 or 180 part, or the minus p plus p part. I know minus p's up here in front.
Yeah, the minus.
Yeah.
But the 360 and 180 thing, I'm scared I'm gonna mess up on the test.
180 is always on the left.
180 is always on left.
Wait, is this
360 zone.
All right, so here, all right, let's write them down. Yeah, so in this one, your reference angle is equal to your angle if it's in quadrant 1, right? In quadrant 2 is a 180 minus. 3 is 180 plus, and 4 is the only one with 360. And it's a minus,
It's like we're gonna have to know,
those 4, and where they are.
Okay.
yeah, that, and you'll have to memorize the positive and
So
But that one's easy because it's the all students take, like, so all, sine is positive, cosine positive. No, sine, tangent, cosine positive, and then everything else is negative.
technically, if you know that it's 0, technically if you know it's 90 to 270, you minus 180 no matter what, and that'll be your answer.
Essentially,
Huh?
essentially.
Is the third quadrant 180 plus p?
Oh, yes. Sorry,
That's fine.
I think my pen skipped out on me there. Yeah, so what is our first step for these? What do we always have to do first?
See if it's
Get it
above or
below
below
360.
360.
Get it below 360 and make sure it's positive. Okay, and then use the formula for whatever quadrant. Yeah, that's pretty much it for this part.
You have to memorize the photos.
Yes. They're easy peasy. It'll be alright. It's one of the rare moments I'll make you remember something. Okay, so that's the majority of it. I will probably put some stuff from the unit circle in there that we learned yesterday. I'll stick it on as a bonus since we just did it this week. Okay.
But we get to take them, so, yeah.
Yeah, you get to use a circle. So did everybody get a chance to finish their chart from yesterday? Okay, well, obviously, Micah, you weren't here. All right, so let's go over that really quickly.
I'm confused on what,
Huh? Confused on what?
on what to do with that.
Oh, yeah, well, I'll teach you.